So hi, everyone. My name is Samantha Quinn. I am the PI and the program director here at POET. We are the network director for the TEAMER program. And we thought that since we are 4 years into the program, and it's been a while since we've kind of shared our progress, that we would just highlight some of our achievements and some updates to processes, as well as we'll hear from some of the facilities within the network. So again, this is kind of what we'll go through. So we'll go through some data as far as TEAMER to date, what we've accomplished. We'll talk about facilities. And then we've also we've had several workshops this year, which is something new. Excuse me. New and exciting. And then we also have some changes that we've made and some upcoming developments for the program. So we'll go through those, and then we'll hear from Marine Situ, University of Maine, and Sandia National Labs, three of our facilities. And then we will have time for questions at the end. So you can put your questions in the chat, or if there's a Q&A box, you can put them in there, and we will answer those at the end. So we'll start going through them. So to start, we did launch the first RFTS in May of 2020. So that was to coincide with the ICOE conference. That ended up being a virtual conference, but we achieved what we went to do, which was to kind of launch that to coincide with that ICOE conference. So that was May 2020, and we have just closed our 13th request for technical support on June 28th, 2024. So we've had 13 rounds. We've been able to support 153 projects to date. And we are currently planning to support through RFTS 18, and hopefully we'll be able to go beyond that. But right now, with our current funding, our RFTS 18 would close in February of 2026. So these are also our testing categories. As you can see, as we've progressed through the project, we have added new categories. So we originally started out in 2020 with the numerical modeling, lab bench, tank, basin, flume, and tunnel. And then you can see that we added some open water capabilities and facilities in 2021. And then our most recent was adding the expertise category in 2022. And I will say that right now the website shows when the next two RFTS rounds are closing, and we will continue to update these closing dates as we get closer and as we get through each of the rounds. So our website always has the latest information, so I would urge you to check back there often. So this is just some more information about those 153 projects that we've supported. So 6 of those have been in the expertise category. 75 numerical modeling, that has always been our largest category that we've received applications and that we've been able to support applications for. 18 lab and bench projects, 43 tank, basin, flume, tunnel projects, and then 11 open water. We have a 49% acceptance rate, which may not seem great, but in reality, we are working on 153 projects, which is pretty spectacular, out of the 300 and I believe 12 that we have that we've received, and we've been making different process updates to help that acceptance rate go up as we kind of move through the program. We also have 54 of those projects at national labs, and then 99 of them at what we call non-national lab facilities. So that is universities, private companies. And I think that that just shows that we have a great spread of projects using all of the different types of facilities that we have. So the national labs, the universities, the private companies, which I think just shows that there is that need for different types of support. This is just another kind of way to see those applications, those that have been submitted and then those that have been supported. As you can see up in RFTS 10, 11, 12, we've really started to get more applications than we had in the past more consistently, which we think is great. It shows that there is still a need for the project and that people are continuing to iterate and apply over and over again. As I stated, we are also continuously working to find ways to improve the processes and to improve that acceptance rate. And I will talk about those later in the presentation. So this is kind of where we are at the moment. So majority of the projects are in that access or post-access phase of their projects. So they are either currently doing testing or they have done the testing and now they're doing their analysis and write-up. If you are a TSR facility who's been working on a project, you have probably been hearing from us. We're trying to close out more of those projects from at least from the earlier RFTS rounds. So I will note that in those early rounds, we did have a lot of delays, especially due to COVID and the many facilities were unable to open to outside organizations, and so they had to push testing back. So we're now just seeing some of those projects be completed. And to complete a project, it means that you have that your post-access report has been approved and that you've also submitted your post-access surveys. So we do request a post-access survey to be completed by both the facility and the technical support recipient. And so you'll probably have been reached out by my colleague Connor over the past couple of weeks to get those surveys in so that we can close these projects out. The great thing is that even over the last few days, as I've been working on putting this presentation together, these numbers keep changing, and we're seeing more and more of those projects be closed out. So I think I even got another survey earlier this morning. You can also see that we have had some projects cancel. Those have been for various reasons, either unable to get the contracting done between the facility and the TSR. We've had some companies that have been dissolved, or we've also had some projects that decide that, you know, they just really weren't ready. So that's kind of where those canceled projects come from. As a reminder, all of the data from the projects is up on MHKDR, and as well as the post-access reports. And so as we receive that and we put them on our websites, and there are links to MHKDR and to TEAMER where the reports live. So this is just a look at the kind of number of projects we've been able to approve and support throughout the years. So RFTS 1, that was our first one. If anyone looked at the application during RFTS 1 or applied, you will have noted that it was a PDF, fill in the blanks on a PDF. So we did get a little bit smarter and started using an online application platform, I believe in RFTS 13. So it's been a lot better, I think, on both the applicant and facility side as well on our side, and be able, you know, with being able to pull reports and just run the review process. So that was a big step. We also updated the application in RFTS, or right before RFTS 8. along with adding those different categories that we went over um, at the beginning. So, RFTS one, that was very much a learning opportunity for us of just like, what does this take to get the application out and to run the review process. And so as we went through all those processes and learned how things worked, we've definitely gotten more efficient over the years. And again, we will continue to try to increase that efficiency and increase that acceptance rate and hopefully make it so that more people are able to receive funding from us. And I believe when we first started the program as well, we were going to be trying to run the RFTS rounds I want to say every three months or so. And now we've increased that a little bit to every 4 months. So we have three RFTS rounds or three opportunities to have an application reviewed a year. And that's just because we found that trying to run almost simultaneous reviews was really difficult with getting enough reviewers and enough team leads. And so we kind of spread that out to 3 times a year. Moving forward, as always, the open water support application is always open, and we do review those on a rolling basis. Just looking at the past year, I want to highlight that we've been able to support 60 projects. So I'm pretty excited about that. That is, about a third of the total number of projects that we have, which hopefully shows that there have been a lot of repeat customers, and that our outreach has paid off. So as you'll see later, we've been going to a lot of conferences, talking to a lot of different audiences, in hopes that we can draw people from adjacent subject areas to take a look at TEAMER to see if we can support them. So again, which goes hand in hand with the earlier data of the overall projects. Numerical modeling is definitely the highest used area of support, and then followed by the tank basin flume tunnel. And I think as we move forward and people continue to use the program, we'll kind of see that shift. And then maybe shift back again. And then that expertise category, that's still pretty new. Even internally, we're still trying to figure out what that exactly means. And so I'll have more on that later, but I think that we'll continue to see more and more projects within that category as well. And just most recently, we closed RFTS 13. So again, we received 28 applications, which is the same as RFTS 12, but before that we had up in the 30s. So we've seen a pretty consistent number of applications, especially over the last 3 to 4 RFTS rounds, which is great. We want to see this high number of applications. We also saw a high proportion of numerical modeling requests again this round. This was the highest that I believe that we've ever received. So one thing I really want to point out, though, is that we also saw 10 resubmissions of previously unsuccessful applications. We really encourage people to resubmit, to take the reviewer comments to build on a new application, and to answer those comments, and to reapply. I don't think so I would say, please use them. That's what they're there for, and continue to iterate your application, and hopefully you will be successful. We have updated the application so that now if you are resubmitting an application that was previously unsuccessful, you can click a button that says, yes, this is a this is a resubmission. And then you can, we're asking you to make some notes of what you have done to address the comments that were made from your previous application, and in hopes that we see that success rate go up. And then just looking at open water, since it is kind of its own category and it is reviewed on in a rolling basis, we have had 17 applications submitted. With 11 of those accepted. We are currently working on 10 of them at this point because one did withdraw. But these are some really fun, exciting projects. Most recently, a couple members of the poet team got to go up to Igiugig, Alaska, and go on the deployment for the Daisies with the University of Washington, which I did not continue my thought there, and it says University of Daisy, in conjunction with ORPC. So that was really exciting. And then we also got to go up to SWIM to PNNL to talk with the folks from Marine Situ. So and if you keep up to date on the different facilities that are added, we've just added the bore and tidal test site as a new facility for open water. And so we're continuously trying to add more and more open water test sites because we know people want to get in the water ultimately. And now I'm going to hand it over to my colleague, Devin Kokersberger.
Hey everybody, I'm Devin Kogersberger. If we haven't talked before, I'm the project manager for TEAMER. So you've probably gotten emails from me bugging you about test plans or reports or something like that. So I'm here to update you a little bit on the state of our facility network. As of 2024, now that we're 4 years into it, we have 47 facilities. Within that, we now offer over 100 capabilities for testing. These facilities are spread out, and almost half of the US is represented here at 24 states. And TEAMER projects have utilized a full 29 of those 47 facilities so far. Obviously, we'd love to get that number up to 100%, but 4 years in, we're pretty happy with the utilization ratio that we have so far of this facility network. And just as a little repeat down there, you can kind of see what offerings are available across the facility network by different assistance category type. And we can move ahead to the next slide. Here's a quick summary of our most utilized facilities within the TEAMER network. It's no surprise 3 of them here are part of our national lab partners, NREL, Sandia, and PNNL. Those are consistently some of the most applied to, but it's also nice to see within the top 5 that we have both universities represented here by Oregon State University, as well as our private sector partners, such as American Bureau of Shipping. Obviously, these projects are no more important than any TEAMER project, but I think they're a good indicator of where interest and demand has been over the past 4 years of the TEAMER program, the types of testing that people are looking to have conducted. And since we've been focused on the last year or so since our last meeting at the Facility Summit in 23, we've added 9 new facilities. You can see those 9 capabilities are listed out there. It's a nice mix of numerical modeling, some physical testing infrastructure, and we also have the open water site of bore and tidal test that we just added to the network a couple weeks ago. Beyond these, we have another 12 facilities that are either under review for possible addition to the network or have already been approved by our technical board and are currently in contracting and/or the NEPA clearance. So again, it's a great indicator of continued interest in the TEAMER program, and we will continue to announce these further facilities that get added to our network as they come online. So next up in our meeting today, we're going to have 3 representatives from facilities within our network talk a little bit about their sites and their work. So first up, we have Paul Murphy from Marine Situ. Paul, are you here ready to
I am
introduce
ready.
us to your work?
Thanks, Devin. Let me share. Here we go. And Devin, should I leave time for questions at the end? So we have 10 minutes plus questions, or?
Yeah, I think we're doing questions at the very end there of
Oh,
this.
okay, sure. Okay. It's been a while since I've used PowerPoint. Great. Well, hi, everyone. I'm Paul Murphy, and I'm a co-founder and a senior software engineer at Marine C2. And we provide AI-enabled underwater monitoring for marine energy devices and related technologies. And so we're a TEAMER facility, primarily focused on expertise in numerical modeling. And I think that expertise section will be clear as we get into the presentation. What I'd like to do first, just give a brief background of our company and describe how we got started and what we provide as a company, and then get into some specific cases where we've worked as a TEAMER facility and describe how those projects have gone. So I think this, I don't know if you're seeing this little thing. There we go. Maybe that's out of the way now. So Marine C2 got started at the University of Washington and the Applied Physics Lab with a group of people who were working on development of marine energy devices, and in tandem, the development of marine monitoring devices to observe these things in action, and to try and answer the question of what happens to macro scale organisms as they interact or come into contact or in the vicinity of tidal turbines and wave energy devices. And what we realized in that endeavor was there weren't products in the marketplace, either hardware or software, that really met the needs of monitoring tidal and wave and offshore wind devices in these harsh environments. We found that things were either too expensive or limited in features, and as a result, went down the road of developing a lot of these technologies ourselves. So today we're a spin-off company from the University of Washington and APL, and a lot of our core technology began under development at the university, as I said, funded by a combination of grants and from the Department of Energy and the Navy. And now our broader mission is to help grow the blue economy by providing low cost and customizable underwater monitoring solutions. A bit about our team. We're now 6 people. We are still close to the university. We're on at 909 Boat Street, which is just like a 3-minute walk away from the Applied Physics Lab where we all were working for many years. We have fab shops for construction of our hardware and have a large office here with room for all our employees. So collectively, we have over 1,000 days of deployed experience with our hardware and software and 12 plus years of technology development experience. Our technology provides to the market a very unique set of solutions. And I think each one of the pieces of our technology, the hardware, the software, and the data management solutions in and of themselves are valuable. But I think the real core benefits often come from the combination of these things. We've really developed this technology with marine energy and underwater monitoring in mind. And so I think as we go through it, you'll find there are specific things about the way that we have developed this technology that you just can't find available and for the price point that we sell at on the open marketplace. So the first part of our tech pillars is our photobar hardware. In development of this technology at the University of Washington, we were on relatively slim budgets at times and needed things to be inexpensive, but also reliable. We needed things to last for long durations, months to years underwater in harsh environments, energetic environments, saltwater, et cetera. So to that end, we're really proud of our hardware. We've seen it last for months and years at a time. We have methods of dealing with biofouling and all these things. We're always trying to drive the cost lower. So currently, we have a number of machine vision cameras, lights, integration systems, biofouling control systems available. And these are all things that we've deployed. We sell and deploy for customers, but have also used in some of our TEAMER work. So I'll get into that in a moment. The second core pillar that we provide is our software. So the software is really, like as I said, developed with marine monitoring in mind. So on the left here, you can see an example of one of our latest software package in action. This is currently deployed in Squim Bay at the Mackerel facility, PNNL's Marine Coastal Research Laboratory. And here you can see a couple of cameras on the top, stereo vision cameras recording some, not much, marine snow. There's nothing in no targets right now. And then below that, a Tritech Gemini sonar. All of these instruments are connected together into a single software platform, and that allows us to be very accurate and precise about the data that we save, so that we save cotemporal data from different sensor streams and don't save data we don't want, and can control those sensor streams easily and efficiently without having to manage a bunch of different software applications from different vendors. And so we've deployed this software in other environments as well, just to give you an example of some of this in action. This is a hydroelectric dam where we're counting fish. And you can see some of our ML running here. These are counting salmonids and shad, I believe, in this video. And we basically do this to monitor the health population as salmon migrate upriver for spawning. This ML technology is baked into all of our software and can be operated on any of our sensor streams. And we'll show an example of this on the sonar data from one of our TEAMER projects a little bit later here. This is not much to say here, but I just found this video last night and wanted to share it. So this is just taken a couple days ago from one of our deployments. And this seal, I think, is probably trying to eat something off of the front of our system. There's a lot of stuff that often grows on them, and is an easy treat for them. Okay, finally, the last tech pillar, our automated data management. So we've built cloud integration into all our software. So we can manage software remotely. We push data to a cloud repository. We develop databases to display this data. So here, this is all focused on fish passage at one of those hydroelectric sites. Excuse me. We've developed APIs to make it easier for reviewers and others to access the data easily from MATLAB, from Python, whatever their method of choice. And all of these things are things that we aim to provide as a TEAMER facility. So if we're assisting with data acquisition, we also want to assist with making that data easily available and easy to work with and organizing it well. So this is one of our core capabilities that we're really happy about. Okay, real quick, a couple of projects we've worked on as TEAMER facility. One of them, this one goes back to 2021. We've worked with ORPC to monitor for smolt migration around their RivGen turbines in Igiugig, Alaska. So they have deployed now 2 turbines in that river, and I think it's been extremely successful. On one of the turbines, they had several cameras, and it was actually one of our very first projects to help them select these cameras and deploy some initial versions of our software on that system. And then over the course of the last couple of years, we've observed these smolt out-migration events. And you can see the water clarity is quite rough here. Sometimes the smolt come close enough to the camera that you can see features of them and discern them from things like sickleback and other small fish in the river. But oftentimes they are this far away and it's kind of cloudy. Nevertheless, we've been able to train a machine learning-based detector that can detect these. And so it's funny, it's sometimes they just are a little streak on the image, and the ML detector does just fine. So this was the main objective here, was to try and determine if ML-based methods would be applicable for this kind of monitoring mission. And to that end, I believe we're still closing this project down, but I believe we have succeeded in that regard. It's yet to be seen if the monitoring mission needs to change and adapt to the specific questions around the smolt health. But as far as ML-based methods, they seem to apply fairly well to this kind of data in spite of the low quality of the imagery. And then another TEAMER project we've worked on, this is with our alma mater, with University of Washington in the Applied Physics Lab. They were recently deploying a new tidal turbine at Mackerel and Squim Bay, and along with it, a monitoring system that is part of the core, original development of our technology. And essentially needed someone to run it, needed someone to operate this system, help with data management, help with machine learning model development and detection. And so with TEAMER's support, we were able to step in and provide those services to them. And so here's just a quick example of that system, just on deployment day. This was a system with a couple of cameras, a Tritech sonar, 2 BlueView sonars, some biofouling control, strobe lights synchronized to the cameras, and wipers around to keep all those optical ports clean. And there's just an example of it strobing and rotating there. Here's a video that we took of this turbine. There's a lot more than this. This is a really successful deployment, and we're just waiting to be able to release as much data as we can. We're a little bit of a hold, but we'll hopefully be putting out some really great stuff soon. And then I don't know what this is. Oh, right. So as I said, we did a lot of ML detection on this deployment. A lot of the data initially was collected using duty cycles, just sparsely collecting data. just to observe the environment. But that kind of data collection, you know, there's often not a target, not an animal in it of interest in the field of view. So it's really beneficial to run machine learning models continuously on the camera data, on the sonar data as it's coming in, and train those models to detect when something interesting comes to the field of view. And so we did just that with the blue view. And this is an example of a seal chasing a fish. You can see it at some point here. It comes back in. And we've been able to successfully detect this seal using the same exact ML technology that we run on the camera system. And so we're really excited about this in particular and what this means for future deployments with our sonars, because sonars really do provide, you know, really great observation capabilities in a lot of environments around tidal and wave devices. Okay, that's it. I'm happy to answer any questions if we have time. Just a quick view of our team here and a RF code or QR code you can scan to visit our website. And that's the end.
Great. Thank you, Paul. It was really cool to see those the sensor videos show that level of detail.
We have a lot more we're hoping to share soon. And on our YouTube page, we're trying to do some live streams right now of our current system that's in deployment. And this system is in the same environment, but just really close to the dock at Mackerel, and getting just incredible footage. The seals and fish right around the dock are extremely active, so it's just so easy to find good stuff. That's where that one up here came from. It was just a couple days ago. So I could share that YouTube link around when we live stream. That just sends you, if you're subscribed to it, it'll just send you a notification that we're streaming.
Oh, that would be great. Well, thanks again for your sharing Marine C2 with us. Next up, we have Matthew Fowler from University of Maine, who's going to chat with us for a bit about their facility.
All right, hopefully I could find the buttons. They all move when I share my screen. Can everybody hear me?
Sure can, thanks.
All right. Yeah, that was a great video. I don't have anything that can rival your cute seal video, but that was really cool to see. Hi everyone, my name is Matthew Fowler. I am the scale model testing manager at the University of Maine's Ocean Engineering Laboratory. We call it the W2. And we've done a lot of testing work outside of TEAMER, but we're very happy to be a TEAMER test facility in the tank flume basin side of things. So just an overview of our facility. This is a shot of the Advanced Structures and Composites Center, which is the lab that houses our facility. It's located on the University of Maine campus. And it was founded in 1996 through NSF, and that basically covered, I don't know if you can see my mouse, but the little front part of the building here. And then we've just been growing, seems like every 5 to 10 years ever since. We're now a 100,000 square foot lab. And one of the newest additions is the wind wave lab. So this section in the back that has the conspicuous pool windows on it, that's where the wind wave lab is located. But our facility as a whole, we employ over 350 people. We do a lot of work in composites, structural testing. This whole building on the right-hand side is a wind blade test lab. You can see the tip of a wind blade sticking out here. So we really support a lot of industries, more than just, wind wave testing. But looking at the W2 facility itself, out of those 350 employees, 7 of us run the basin, including myself. So a number of engineers focusing on either model building or technicians or instrumentation, numerical modeling. We can really cover any aspect of what you would need for developing a test, developing a model, figuring out what you want to run, how you want to simulate things. And then as far as what we have engaged with TEAMER on, it has been testing in our facility. So you can see in the background here, that's our wave tank. It's 30 meters long by 9 meters wide, and it's 5 meters deep. In the foreground, you can see our 16 paddle multi-directional wave maker. It's the same make that Carderock has, just obviously a lot smaller. On the far side of the basin, you can see our wind machine. We do a lot of testing in the floating offshore turbine space. That's kind of where University of Maine is doing a lot of its technology development. So this facility was really kind of focused when it was designed around supporting testing of those types of devices, but we've done a lot of WEC work, wave energy converter work since opening. And yeah, just the specs of what we can do. We also have a tow carriage. The white frame gantry you see here. This picture is a little old, but this gantry is now motorized, so we can pull things through the water. I wanted to highlight some of the capabilities we have. As some of you may know, it's hard to put everything that your facility can do on like a TEAMER brochure, especially when a lot of our capabilities are custom one-off kind of model design and building, which is not something that TEAMER explicitly supports financially, but is often something that we have found teams need a lot of help with. They either have really good numerical models or they have a really good idea about what they want to do, but they don't necessarily know how to test it. What type of model do they need? What level of complexity do they need? What things do they need to simulate versus what things do they need to physically build and model? And unfortunately, most of the TEAMER work we've done is still under kind of an embargo, so I can't show you the recent stuff we've been doing, but here's some of the other work that we've done in our facility. In the picture here, this is a WEC model that we designed and built for a client. It's 1:15 scale. This was done back in 2019. But we designed this model and tested it in our facility here. And this company is now actually testing offshore, which is always exciting to see. It's nice to see something that starts off in the basin end up out in the ocean. We also have the world's largest polymer 3D printer, which we have recently been using to prototype and build models. One of which was we built this 3D printed boat. So people may have seen that in the news. It got some like Guinness World Record for the largest polymer printed object. So obviously this isn't a scale model that we tested. This was more of a demonstration, but we're using additive manufacturing in a lot of our model designs now. We find that it's a very cost-effective way at producing some of these custom geometries that are very important to the hydrodynamics of the model and often hard to reproduce with traditional manufacturing methods. So we're very excited to see that technology come online. And again, I mentioned we do a lot of work in composites. So this is a composite blade that we built for testing an offshore wind turbine. So we can make the molds, pull the composites, do all that work as well. Some of the instrumentation and controls capabilities that we've added. Again, we've done a lot in the offshore wind space, but we've done a lot with hybrid testing and real-time controllers. We have a Qualisys motion capture system that can record both above and below water motion of devices, which is very advantageous for getting real-time feedback. So you can have 6 degrees of freedom feedback of testing that you can feed into controllers or other things. We have a full array of National Instruments hardware and software that we can develop and deploy as needed. And as well as we can also run real-time simulations to do hardware in the loop type testing. So along the bottom of the slide here, you can see this is a hull we designed. It's a 15 megawatt turbine hull. And we integrated some tune mass damper hardware in the loop type actuators in the outer columns here. So each of the outer columns contains a hardware in the loop style actuator. So this type of model design and implementation is similar to what we've also used for wave energy devices. But since I own this IP, I can share it. Usually the PTO and the details of what they try to do is stuff that I can't share. Talking about the projects we've done. So you can see on the right-hand side, that's that floating turbine I was talking about. That was an extensive test campaign we did. It was not TEAMER funded, but it supports the general mission of open data sets, making data available to researchers. We worked with NREL on that. So we really support the mission of TEAMER and appreciate that data sets are made available on the directory while also maintaining protection for the IP. Like we really appreciate that mechanism. We've done over 20 model scale test campaigns since we opened in 2015. And as I mentioned, 2 of those technologies have progressed to open water testing, which is great to see. We've done a lot of work with one specific company on in TEAMER, but their stuff is still under embargo. And then in the floating offshore wind space, the testing I'm showing here, that's a 1 to 70 scale. But UMaine is also progressing our technology to the open ocean. And so one thing I wanted to introduce here is our intermediate scale testing that we can do. This open water site is not currently on TEAMER, just because it is honestly, it's quite a lift to go from the basin to offshore. But it's something that we're interested in pursuing and making more available. We've used it as a test facility for, as you can see in the picture here, this was 2013. We deployed a floating wind turbine there. It's off the coast of Maine. So it's actually, it's a small kind of semi-sheltered cove, but during the winter, we get very good representative environments for testing design load cases at scale. So it gives you a good chance to deploy something kind of in the calm summer months and then bunker down in the winter and collect all the data you want and then pull it out the next summer. We've tested a number of devices here. Here are some examples. So as I mentioned, in 2013, we did a DOE funded floating offshore wind turbine. We've done some breakwaters and other items for the US Army Corps. We have deployed wave energy converters there. We just recently did, and we're planning an upcoming offshore deployment this year for another floating wind turbine. So that's what the site's going to be used for at least the next year. We're deploying a 1 to 4 scale technology. So this is an iteration of the technology that was deployed in 2013 with some new things added to the hull. So a lot of work that we're really excited about, and we would love to see more wave energy testing here. We'd love to develop this as a test site. So I think with that, yeah, that's what I had. I'll just leave this little exit video here. And yeah, if we're taking questions at the end, that's great. Otherwise, I think I was a little quick. So if there's any now, I can take them. But that's what I've got.
Great. Thank you, Matthew. It's a great facility that you guys have up there. Also very cool to see the additional work you guys are able to do there outside of TEAMER. So thank you very much for sharing with us.
Definitely. Thank you.
And then our third facility representative today is Dom Forbush, who's with Sandia. So if you would like to take it away for your.
You guys hear me? All right. I'm seeing some nods, so I'll go ahead. I'm Dominic Forbush. I'm Senior Research and Development Engineer at Sandia National Laboratories, and I'll be giving an overview of a selection of some of the TEAMER facilities at Sandia. This is the list of the ones that are shown on the TEAMER website right now. I'll be presenting one that's soon to be there, hopefully, but maybe not yet. The ones in green are the ones that I will be presenting today that I'm actively involved with. So if you have detailed questions on those, I can hopefully field those for you. The ones in blue are ones I'll be talking about, but I'm not actively involved with. So I'm happy to get you in touch with the right person in case you stump me with a hard question. So I'll start off talking about the WEXIM facility. This is the Wave Energy Converter Simulator. It's a software that lives in MATLAB Simulink and is a really flexible, we call it mid-fidelity modeling tool for wave energy converters at various stages of development. This is actually a joint facility between both Sandia and NREL. And so when a project comes in, we sort of triage amongst ourselves to get you to the right people to solve the problem. You might end up with just Sandia folks or just NREL folks or some amalgam of both, but we make sure that the right expertise is put on the right project. And I'll show a couple of examples of utilizations of the WEXIM facility here. In this case, a company came to us and they had both a tank scale oscillating water column with some test data, and they wanted us to build a WEXIM model of this device so that they could simulate their deployment scale device and gain some insights as to the power takeoff design and control of their larger scale device. So the Wexim workflow, I missed to mention this, is we kind of start with a geometry and work all the way through to potentially component level power takeoff models. And so this is an example of somebody who kind of comes in on the left-hand side of this flow chart, and we get up to a modeling level. If you have a fully fledged operational WEC with component level things that can also be handled in Wexim, will just kind of be more on the right-hand side of this flow chart. So yeah, here we had models. So we defeatured the initial rendering on the left there, created a mesh, got some good boundary element method results, and then tuned the Wexim model that we built with their test data. And we were able to use that to inform a couple of parameter studies on their deployment scale device. And one caveat with Wexim is because we do start with a geometry and we need boundary element method results to advise Wexim. If you have kind of a big matrix of geometric parameters of interest, Wexim's probably not the most efficient way to go, because every time we substantively change the geometry, we have to go back kind of to square one with the modeling to some extent. In this case, they just had a couple of different parameters they were looking at. We were able to investigate those parameters' effect on their potential eventual PTO design. So sort of counterexample to that point is an ongoing award, actually, where a partner came and is seeking kind of a feasibility study for a bio-inspired point absorber attenuator consisting of a series of hinge connected floats about a central node, or a node at one extreme of this platform. And he's very flexible as to the potential design. And so this is a case where the optimization of the geometry and the understanding of those parameters really is a first and pressing priority. And so in this case, we're starting actually with WECOP tool to drill down to a handful of kind of the most viable geometry and PTO configurations for the possible C state. And then after we do that, we can then take resulting geometry and put it into the Wexim workflow and investigate kind of that down selected geometry subspace at kind of a component level, study control, study PTO, all of that sort of thing. So that is to say, no matter kind of where you come in with the modeling needs, we can either address your needs directly within Wexim, or certainly steer you to a tool that might be better suited for where you're at in your design process. So sort of on that note, another Sandia facility is the Marine Energy Converter Assessment Software Facility. And that encompasses all of the software and numerical modeling stuff at Sandia that doesn't fall under our Wexim or our high-powered computing group's umbrella. So that includes things like WECOP tool, MHKit, SNL Delft 3D, all those Sandia developed softwares that you may have heard. Well, we can definitely apply them to problems, and this is where you would go for us to do that. In this particular example, we had a company approach us who was interested in deploying a novel tidal turbine from a particular sort of vessel. And so the question that they were asking was, for a given vessel and tidal resource, what sorts of parameter ranges should we be looking at that will lead eventually to an optimal turbine design for that site and vessel pairing? So obviously nothing directly out of the box was going to answer that question, but we're able to leverage a lot of existing software tools and write some novel code to group it all together. We relied on things like Aerodyne from NREL, MHKit, and some custom Python code wrapped around all of it to answer their design questions. I'm going to just talk briefly about the technology performance level assessment facility at Sandia. This is another one that is shared across Sandia and NREL, and I know that we triage applications in a similar way, so you might end up with personnel from both labs working on your project as appropriate. I won't talk about it too much because there was a very recent webinar hosted by TEAMER here about 6 months ago. That still has a lot of the best available information there. So I can drop, I don't know if the slides are going to go out, or I'll drop this link in the chat when I'm done. You can go check that out on your own time. But I will say, I think this facility is a bit underutilized and has some potentially valuable insights to share. So I'd encourage you to check it out if it's something that might be of interest to you. That brings me to the end of the facilities that I am presenting today that I was actively involved with. So moving forward, this is work by other facility leads at Sandia. The first of which is one that's not actually listed yet on the TEAMER facilities website. It's our structural mechanics laboratory, which is essentially a very highly configurable loads and materials testing type facility housed at the lab. The example application of that I'll be presenting is the calibration of the strain gauges on the open source tidal energy converter blades. This is a joint project between Sandia and the University of New Hampshire. It's about a 1 meter scale turbine that's going to be deployed at the Living Bridge at the University of New Hampshire's facility. And they're going to test it and characterize this turbine according to the IEC-3 standards, which has some very specific requirements as to the sorts of loads that need to be measured. And so this blade instrumentation includes some inbuilt strain gauges, both within the blade itself and on the connector hub there shown in the bottom figure. So the question becomes, how do you calibrate those inbuilt sensors for the necessary characterization efforts according to the standards? You can see the two different test rigs, both in a conceptual rendering and an as-built. Depending on the blade position, kind of in that circular jig, we're able to test flapwise and edgewise moments. And in the bottom there, that's a similar test rig, just torsional. You're able to characterize the stress strain relationship of the blade, and more importantly, in this case, get some very useful calibration data for those built-in sensors. So if you see yourself with similar sensor calibration or materials property testing needs, this might be a facility for you to consider as well. The lake facility is a very large outdoor basin, somewhat ironically placed in the middle of the desert in Albuquerque, New Mexico. And I say large, it's 120 feet by 188 feet, and it's 50 feet deep. So it might be able to accommodate what you would consider a full-scale device, depending on, of course, the scale of that device. And I'll note that the basin itself doesn't have a wave maker, and it doesn't have the ability to generate currents like a flume. But it is, a large basin suitable for some in-water tests. Has a really large tower next to it. It's used for drop tests for other typically not marine energy related applications. And there's a few shipping containers that you can put equipment into and interact with the tank from, staged around this facility. The particular sort of test that exemplifying today kind of talk about is there's a proposed method for testing mooring and umbilical fatigue strength or ultimate strength by storing this sort of apparatus in one of those shipping containers. You could deploy the WEC device at nearly full scale and actuate the ends of these cables in a similar way to the waves, even though we can't generate the actual waves themselves and characterize their strength and anticipated lifetime. So that's one potential application of this facility, but really it's just a really, really big pool suitable for whatever in-water testing you would like to try out. The SWEPT laboratory is the Sandia Wave Energy Power Takeoff Facility. Perhaps one of our more famous facilities. If you were at the Oregon State workshop in May, a portion of the SWEPT lab made an appearance there. This is capable of testing wave energy power takeoffs in particular at full scale or something very near full scale. In this image, that's the aqua harmonics power takeoff there in the left half of that shipping container. And then on the right half of that shipping container, we have a very powerful and precise set of actuators that are able to simulate the excitation force exerted by the waves on your actual PTO. So for things like the system identification, control study, lots of different characterization kinds of your actual PTO hardware, you can do that in the SWEPT lab. We've developed a very robust and precise series of test procedures to accomplish those objectives. And our testing procedures have been adopted in the most recent batch of both the European and the IEC 62600 testing standards. I have a link to a cool YouTube video here that I was worried wouldn't render properly, so I'll drop that in chat as well. I encourage you to check it out. The last one I'll talk about is the Distributed Energy Technology Laboratory, or DETL for short. This is kind of another step up the ladder of abstraction from a full-scale wave energy device. Here we have a back-to-back motor generator configuration shown in that central image there surrounding that blue box. And in this case, we're simulating both the force input from the waves or the current. In this case, we can do current energy as well. And the generator is going to be simulating the action and dynamics of the power takeoff. What's really unique and special about this facility is it's connected to, on the backside of that generator, a very detailed, well-instrumented and configurable microgrid. So you can vary the scale of this grid, you can incorporate energy storage elements, other generation sources, renewable generation sources, and understand how your device will interact with potentially a microgrid, or how that microgrid may be affecting your device. And even aside from the grid connection, provided you have good models of your power takeoff and your excitation, you can perform lots of controls investigations and optimization studies on this sort of power and or hardware in the loop platform as well. And that's everything I had to talk about. So thank you, everybody.
Great. Thank you so much, Dom. We appreciate you stopping by to share some of Sandia's many offerings with us. Sam, I'm going to pass things back to you if you want to take us home on these last handful of slides.
Great. Yeah. Thank you to all of the facilities who presented today. I just want to talk about kind of some upcoming, well, some new things that were added over the past year and a half, and then some upcoming changes to the program to finish us out, and then we can have questions. So in 2022, workshops and trainings were added to our scope of work as far as TEAMER goes. And so we decided that we wanted to do a mixture of in-person workshops as well as virtual. So the virtual workshops are more informational. So as Dom said, we held a TPL assessment webinar back in January, and that was to highlight this capability at Sandia that has kind of been underutilized. And so I do suggest that if that you go and watch that webinar. If you're kind of if you want to learn more about your own technology, it's a really useful tool. And then we've also held the how to write a successful TEAMER application. So that was more to answer questions about really like how to write a TEAMER application that is going to do well in the review. Make sure that you have the correct details in your application, stuff like that. So both of those are on our website. Any of those virtual webinars or any of these or things like this are always going to be available on our website. So I suggest that if you're interested, go take a look. And then the in-person workshops are more technical. So we just had our first in-person workshop in May that was held at Oregon State University. That was our WEC modeling and controls workshop. And so this was more of an intensive, week-long intensive workshop, and I'm going to go into that a little bit more. But again, these are things that we want to do more of. And so we're going to put a survey in the chat that if you have ideas of any types of trainings or workshops that you would like to see, please fill out the survey. We want to make sure that the workshops that, especially the in-person workshops that we put on, are going to be useful to the facilities, to the developers, not just to put a workshop on for the sake of putting a workshop on. So if you have any ideas of what you want to see next, please fill out that survey. And then I'm going to go a little maybe into that modeling controls workshop. So this, like I said, was a 5-day in-person intensive workshop. It was held at Oregon State University. We had 39 participants. Those were from national labs, universities, as well as private companies. We also then had about, I want to say like 15 different instructors. Again, we had people from the national labs. We had the SWEPT lab there. They shipped that, Sandia shipped that up to OSU. We had university instructors, and then we also had some people from private organizations who are just, you know, experts in their area who we brought in to help lead some of these modules. So in preparation for the workshop, we had all attendees we had all attendees go to pre-workshop modules, just virtual modules. That was to make sure that people knew what to expect, and also to hopefully get some of the software downloaded and ready for when they were at OSU. Basically, they started at resource assessment, went through like WEXM modeling, then through the physical modeling in the flume. Again, then they had scale controls. I guess lab, mini lab that was brought, and then the SWEPT lab was there as well. So it was, in my opinion, so just interesting to see everything from kind of start to beginning. And then the other thing was we had people who were just starting out masters to tech developers to university professors. So kind of a whole range of knowledge. And so it was, I think everybody walked away with something, which is kind of what we hope to achieve. So again, we want to do more stuff like this. So if you have any ideas, please do let us know. Okay, and then these are the main updates that we have made over the last year. So the first bullet there is looking at that. And any applicant may not submit more than 2 applications per RFTS and may have no more than 4 active projects. This is to help us ensure that like projects are getting closed out, that people are finishing that TSRs and facilities are doing what they said that they were going to do and are letting the projects run their course and closing them out before we fund additional projects. We want to make sure that, you know, that the data becomes available and that the project post-access reports become available. We also made this rule that applicants, if they do submit more than 1 application in an RFTS, they need to show that there are no codependencies between the applications, because again, we don't want projects to be drawn out because they're waiting for data or something from another application or another project that's ongoing. And then we just want to reiterate that multiple facility applications are permitted, but we really want the TSR and the facilities to show us that there is coordination between the facilities. So again, to make sure that the projects are going to be carried out in that timely manner, and just to make sure that there's coordination and that there is collaboration on the projects. This is probably everyone's most exciting bullet, but that applications, we have increased the funding amount for applications or for projects. So we went from 150,000 for non-open water testing to 200,000, and then from 200,000 to 400,000 for open water testing. We realize that a lot has happened since we first started this program, especially inflation. And so we know that you can't that you may not necessarily be able to get as much bang for your buck. And so we wanted to make sure that our funding amounts kind of were increased to match current, I guess, rates for 2024. So we made that change earlier this year. So we have the do not exceed amount for non-open water for 200K and then open water for 400K. In addition, we also know that travel has gone up a ton over the last 4 years. So we've increased that travel support if the TSR is going to be traveling for a physical test. We've increased that to $2,000 a week for travel support. Again, the TSR does need to let us know if they need to request that travel support so that we're aware of it. And then they basically don't get their reimbursement until their post-access report has been approved. And so again, another way to entice people to get those projects done and get those reports in and the surveys completed. Another new rule that we've made is that TSRs and facilities will have a total of 5 months after selection notification to have their final test plan approved. We had noticed that there was sometimes a long lag time between when we made selections of support and to when their test plans had been approved. This was both because of TSRs and facilities, but also with the on the team lead side of actually approving the test plans and providing comments back to the TSRs and facilities. So we put this new guideline in hopes that it will help the delays on both sides. And then as I mentioned before, we added a new question to the application for resubmissions to help applicants be more successful. So again, taking into account those comments, the reviewer comments and team lead comments that as a TSR and facility that you receive regardless if you're successful or not. And so hopefully by having those and having this direct question of how did you address those comments, this will help both the reviewers understand how you address those comments and also just make it very, very clear to the reviewers of what you've done to address the comments. So hopefully this will again help that success rate go up. And then we also have some other program updates. We are getting a new website. So we know that the TEAMER website is clunky and that the search function is not great. I will say that I helped to design this website in 2020, and I am not a web developer. So we have contracted with an actual marketing company who does website development, and they are working on updating or creating basically a brand new website. It'll be the same URL. It'll just look much better and be a lot easier to find what you're looking for. So that should be coming online in January. And then we are going to also start offering conference presentation support. So we will pay for travel registration up to 5K for you to go present your project, paper at a conference. So the details of this are not yet on our website, but they will be coming soon, and we will make an announcement when that is available. We also will be adding journal paper support. So we will be providing funding for journal papers to be written. So that information will also be coming over the next couple months. Hopefully that is enticing for people to once again disseminate information, disseminate, what they've learned. In addition, we have increased our reviewer rate. So every project, every application that we receive gets reviewed by 3 expert reviewers. That we do pay for. So we pay $200 per review. And then if you are team lead, which means that you basically go out and find the reviewers, of which we have a large database of. So you're doing kind of the coordination of the review and of those people. And then if a project is successful, you would also be doing the review and approval of the test plan and the review and approval of the post-access reports. So we are always looking to expand our reviewer database. If you are not in there, then, and you would like to be, you can send us an email and your CV to the email address on the screen. That email is the best way to get to us because it goes to all of us. But basically, if you want to, in your email, if you could tell us like what your area of expertise is and kind of that you would like to be considered, then we can add you to our database that then our team leads use. And if you are added as a reviewer, we will be doing hopefully in the next coming months, we will be putting on reviewer training as well as team lead training. And then we are also going to be, for the facilities on the line, we're going to be updating the facility application as well as the criteria, just to make it a little bit more clear of what we're looking for. And then finally, we are going to be adding commercialization as a new category. So this new category may take the place of expertise. We're still trying to figure that out. But really, we want to find things that work for the developers, for the researchers. So we will be we'll be reaching out to developers and researchers to gauge their needs and opinions as to what will be helpful in this category. So it could be things that could fall under this category would be like engagement with investors or like public fund, like proposal and pitch consultation, regulatory consultation, stuff like that. So we're putting all that together, and we will be reaching out to developers about those types of commercialization testing that may be available to see what will be helpful and what will not be. And then I think that is all. Oh, one final slide. I think I stated earlier that we've kind of seen the number of applications grow over the last year, which has been great. And as you can see, we've been doing a lot of outreach. So in addition to like our social media outreach, we have a TEAMER Tuesday most weeks, and that's either talking about when an RFTS is due or new facilities or that we're at a conference, stuff like that. You can see that we've also been going to a lot of places to do a lot of outreach. So we have gone to Water Power Week. We went to Ocean Science meeting this year, Offshore Technologies Conference, and then POET holds the OREC conference every year in Portland. Devin and I will be traveling to Australia for ICOE. We'll be at the International Conference on Coastal Engineering in Italy, and then we'll be at Ocean Energy Europe. In addition, we have been trying to go on more site visits. So this is something that we've always wanted to do since the beginning of the program. Obviously, COVID prohibited some of that at the beginning, so we're kind of playing catch up. But we really want to get out to all of the facilities at one time or another to see the tests that are happening and to talk to people to just make sure that TEAMER is being helpful and what you're gaining from it. So So we've recently been able to go to quite a few, and hopefully have a few others coming up later this year. So if you know your test dates and you want us to come, please reach out to us. We are also reaching out to all the test facilities. So, but yeah, we want to come. We want to see all the great work that you're doing. So with that, we can open it for questions. And yeah, easiest way to get in touch with us is teamer@pacificoceanenergy.org, and then visit us on our website. Any questions for us or for any of the facilities? Yeah.
I got a question on LinkedIn on one of our posts just yesterday, and it's one we get fairly often.
Great.
Is TEAMER open to international applicants?
Yes, TEAMER is open to international applicants, absolutely. I will say that after we went to OEE last year, we got an influx and continue to see more and more international applicants. The only thing is that we cannot pay for any travel for those international applicants at this point due to some DOE constraints. So we're hoping in the future we may be able to, but regardless, yes, they're absolutely available, or TEAMER is open for them to apply to. Thanks for that.
Great, thank you.
So we did get a question. Does TEAMER work with others such as EMEC? We do not have any international facilities. For TEAMER, all of the work has to actually take place in the US. So not technically. Are there any opportunities for follow-up assistance after we have gone through the TEAMER program, and how can we figure out what facility would be best to work with? You can apply for TEAMER, you can apply to TEAMER over and over again. And we can help you figure out which facility to work with. So anytime, if you know that you want to do some type of modeling, but you're unfamiliar with the facilities or their capabilities, feel free to reach out to us and we can help match you with a facility.
I'll add to that that once the new website is live, our search will be much more robust. You'll be able to search geographically in addition to just through capabilities or research areas. So yeah, we're all excited about the new website and what it's going to bring to TEAMER and the applicants and the facilities.
Yeah.
But in the meantime, we're happy to help.
Great. Well, if you have any questions that you think of after, feel free to get in touch with us. And then, yes, if you do have any ideas for future workshops, again, we want to hold workshops that are actually helpful for you. And I guess one thing I did leave out was that we pay for your travel. So hopefully it's of great benefit for you. Awesome. Well, thank you, everybody, and have a great rest of your day.